So we have already kind of talked about the continuity, right? So we're going to skip this first warm up here because it's basically the example that we just talked about. However, we have not talked about examples like number 1 here when we're given a function without a graph. And we need to identify what are the x values where it's not continuous and identify what the type of discontinuity is, okay? And then we have to write the intervals which it is continuous on. So we need to kind of flash back. We got to think back to like algebra 2, pre-calc. How do I figure out at what point, right, I'm going to have some vertical asymptotes? Anyone remember how do I find a vertical asymptote given a function? Yeah.
You have to factor the bottom and then set x equal to 0.
Yeah. Yes. So we definitely have to factor, right? And then the denominator will set them equal to 0. How am I going to find out if I have a whole? How do I know if I have a whole? If anything cancels on the top and the bottom or simplifies to 1, right? So first task for you guys to do is go ahead and factor that numerator and the denominator, okay? Factor the numerator here and the denominator. And then see what happens. And then think kind of what are maybe these x values giving us when I solve these. Okay, I'm going to give you a minute to do that. Okay, I'm seeing a lot of x plus 8, x minus 5, and x minus 5, x plus 2 in the denominator. We all agree? Okay, so based on the denominator is going to tell us, or actually first of all, what is going to simplify to 1 on the top and the bottom? X minus 5, right? The x minus 5s are going to simplify out, which means we are going to have a whole, right, at x equals 5, which if it's a whole, that is a removable discontinuity. Okay, then we talked about the denominator. This denominator, if we set x plus 2 equal to 0, that's going to tell us specifically the vertical asymptote that it's going to have, right? So we cannot have at -2, so at x equals -2, if we have a horizontal asymptote, right, that is going to be a non-removable discontinuity. Okay? Make yourself a little note because it makes the denominator equal to 0. Which is your vertical asymptotes, okay? So if you struggle with being able to think of like numbers from left to right, how am I going to write the function, the interval that it's continuous on, you could kind of sketch yourself just a little picture here, right? If I sketch a little graph, I know at 5, I'm going to have a hole somewhere. I don't know where it's going to be, right? And then at -2, I'm going to have some sort, right, of vertical asymptote there. But my function could look anything on the left as long as it doesn't touch that, right? It's not going to actually approach that or touch that vertical asymptote. So maybe it's going down like that, and then maybe it's going like this, right? I don't know what exactly it's going to look like. I don't know that unless I graphed it, right? However, we do know the only 2 points that are not going to make this function continuous on are at -2 and 5, right? So if you need to draw yourself a picture to help you think of how to write your intervals, you can. But to write my interval, I'm starting from the very far left, which would be -infinity for my x's, to -2. And then I'm going to be from -2 to 5, and from 5 to infinity. So this would be your interval on which g of x is continuous. Cool. All right. Let's go ahead and head to the next page and look at example 2. Example 2 is a graph. You're going to have quite a few problems on your homework on the front page that are graphs. If you look at a graph, is it continuous at this point? Yes or no? Why? So you're going to get in the habit of writing the 3 things down, right? The limit on the left approaches the limit on the right. Is that equal to the function at that point? So we're just going to do one of these. Let's just do the x equals 3. We'll cross out x equals -6. We don't need to do that one, okay? But if I look at this graph, I need to write the following things down. As I approach from the left at 3 of my function, what do I get as I approach 3 from the left? What is my value? Do we agree? 6. As I'm approaching from the left, it's kind of funky because there's that vertical asymptote there, right? But it is approaching, right? From the left, it is approaching 6. So your limit from the left is 6. Then the limit from the right is going to be what? Also 6. Okay. And then we know that the point, so f of 3 is -3, right? It is not the same. So this would equal -3 at that point. So we find those 3 things. Now we determine if it is continuous or not. Is this continuous? Are they all the same? No, so we would say no, it is not continuous, or just say not continuous at x equals 3. It's going to ask you at a specific point, so you have to make sure you say at what point it is not continuous at. And then give your reasoning, okay? A lot of the time it'll say justify. So we would say something like the limit as x approaches 3 of our function does not equal our function at 3. All right, then example 3 kind of takes us back to that piecewise function again, like we did on that previous Starbucks page. So we're asking, is it continuous at 2? Justify your answer. So we need to find 3 things. The limit as it approaches from the left, which means we're going to use the top function, right? If I want to find the limit as x approaches 2 from the right, I'm going to use the bottom function. And then which function am I going to use if it's equal to 2? Also the bottom one in blue there, okay? So I'm going to give you guys a few minutes right now. Go ahead and list those 3 things out and then justify for me if it is yes or no and why. I need a justification statement, okay? All right, so we should have gotten 3 for all 3 of those things, right? Just some quick notation I just want to make sure we are aware of, okay? If you are just writing this limit as x approaches -2 of f of x, okay, I don't know what function it is that you're plugging it into, okay? So I need to at least see this second statement here of which function you used. And then if you don't show me all of this step, that's okay, but I do need to see what that answer output is, okay? So at the bare minimum, I need to at least see this piece and your final answer for both sections, okay? The other stuff is just extra. If you're people that like to make silly mistakes, it might be better to write that out. But as long as you have that stuff highlighted there in yellow, you would get full credit for a problem like this, okay? The other thing that you would need if it said to justify your answer, like I believe this one does say, is we need to first answer the question, is it continuous at 2? Okay, yes or no, and why? So is this one continuous at 2?
Yes.
Yes, so we would say yes, f of x is continuous at x equals 2. Okay. Because your limit as x approaches 2 of our function is equal to our function at 2. Okay, a statement like that would be good enough to show me that you know what it means to be continuous. Okay? All right. Example 4 here is pretty much using the same idea from example 3, except for instead of just doing it at one point, it asks us, if we have this piecewise function h of x, determine all of the x values where it's discontinuous and classify those as removable or non-removable points. Okay? So how are we even going to know what points to check? Well, let's look at our ranges here, right? Or our domains for our x's, right? So if I'm at x is less than -2, I have this function, 2x minus 1, but then the instant that I'm greater than 2, I have this function, x squared minus 9. So what do you think a point that we're going to have to test is? Not 3, -2, right? You're testing those points in between or on where that function is changing for your piecewise. So we need to test x equals -2. We would also need to test, oh, wrong color there. This is at 3x plus 2 is at the greater than 1 versus less than 1. So that means we're probably needing to check x at 1. And then what would the last one be that I need to check? x at 3. So I need to check 3 points here. Now, we're not going to do all 3 points right now because it's going to be basically the same thing over and over again, right? And I want to have you guys have some time to work on your homework, but we are going to at least talk about all 3 of these, okay? Specifically, the one that I want to talk about is x equals 3, okay? So let's quick find the limit. If I look as I approach 3 from the left of my function, I would be using that function in green there, right? So the limit as x approaches 3 from the left of 3x plus 2 would give me something like that, which would be 11. Now if I approach it from the right, of my 4x minus 1, bless you.
Thank you.
I plug in 3, and I get also 11. Now, what is the issue with my function at 3? Which function am I going to use?
Like none of them are equal to 3.
None of them are equal to 3, are they? This symbol right here that has 3 with it does not have a greater than or equal to, less than or equal to sign, right? So f of 3, we don't know what it is, right? F of 3 is undefined because it is not part of that domain, right? So since it is not defined, that means at 3, at x equals 3, there is a removable, right? A removable discontinuity. Okay, and it's removable because if I draw a little picture here, again, pictures can help. We know if I approach 3 from the left, I get an output of 11. So I don't know, maybe my graph looks like that, okay? And as I approach 3 from the right, I don't know, maybe my graph looks like this, okay? But f of 3 we don't know. So that's actually an open circle there at 3. Oops. Okay. So it's removable though, but it is undefined. So it's not continuous at 3, okay? If you guys would like to check later, I'm going to just write the answers for just what x is -2. X at -2 is I don't remember, let's see, what is it? At -2, it is continuous at that point. At x equals 1, it is a non-removable point. Okay, so if you want to go back and check those, you can, and that should be your answer for those 2, okay? Now this one did not say that we had to find the interval on which the function is continuous, so this would be our final answer for these after I found those x equals -2 and x equals 1, right? Okay, any questions on this one? Okay, then let's look at example 5. Next page, right? Yes. Okay, last 2 are going to throw an extra variable at you, okay? It's really not that bad. We just got to set up our equations, and we got to solve for our missing variable, okay? So example 5, we've got this piecewise function. We need to find the value of a that makes q of x continuous at x equals 1, okay? So to find continuity, we got to check the left-hand limit, the right-hand limit, and set them equal to each other. Sorry, they should be equal to each other, right? So let's just start by finding both of those. So if I take the limit as x approaches 1 from the left, the function that I would be using is that x minus 3, right? Oops. So I plug in 1, and I get negative 2. Okay, if I find the limit as I approach from the right of my function, I'm using the top or the bottom one this time? The bottom one this time, right? Because it is greater than 1. So from the right, I'm going to use that x squared. And we have to remember when we're plugging in our values, we're plugging in for x, right? So I'm only plugging in 1 anytime I see an x. I'm not plugging in 1 for a. We got to make sure we're plugging it in for the correct variable. So when I plug in 1, I get 1 squared minus a minus 5. And if I simplify that, I get negative 4 minus a. Well, what does that equal, right? We're trying to find what does a have to be equal to in order for this function to be continuous, right? So what do you think we're going to have to do, Olivia?
Minus a.
Oh, what did I do? Oh, dang it. Okay, plus a, sorry. What do you think we're going to do now? How are we going to solve this? Set them equal to each other, right? So I know that these have to be equal to each other in order for this to be continuous. So I can go ahead, negative 2 equals negative 4 plus a. Quick little one-step equation. What does a equal? 2. Thanks for catching my errors. Okay, so we know if a is 2, the limit as it approaches both sides is going to be equal to each other, right? And then the other thing that we just got to double check is that our function at 1, is it also equal to negative 2, right? So I'm going to plug that into the top equation there, x minus 3. So I got 1 minus 3, which is negative 2. So it is in fact the same. So therefore, the value of a that makes this function continuous is 2. Okay. Questions on that? Okay. And then example 6, our last one before you guys will have some time. We'll take a quick break. But this one kind of sets us up in terms of parts A and B to help us figure out how to do part C, which is the same idea as example 5. We're trying to figure out what values do m and k have to be in order for this function to be continuous, okay? So if I look at letter A, it says what two limits must equal in order for g of x to be continuous at x equals negative 1. Okay, so in order for me to test at negative 1, I'm going to use the top and that middle function, right? For my limits on the left and my limits on the right. So let's just write those out. The limit as x approaches negative 1 from the left of 2, right, has to equal the limit as x approaches negative 1 from the right of our function mx plus k. Okay, those must equal each other, right? Okay. Then for letter B, we're looking at when is it continuous at 3. So at 3, I'm looking at that middle equation and the bottom equation of negative 2. So I'd write the same exact kind of thing out. The limit as x approaches 3 from the left of mx plus k must be equal to the limit as x approaches 3 from the right of negative 2. Okay, so from these two limit statements, we can evaluate what the limit is at that point, and we're going to have two equations, okay, with two variables, which means we're going to have to do what? Substitution, elimination, some type of equation kind of work, right, from algebra. So let's write our two equations out. From letter A, we can write the equation, the limit as x approaches negative 1 from the left of 2. That evaluates to just be 2, right? And if I evaluate the right-hand side as it approaches from the right, I'm plugging in 1 for what variable? There's 3 of them there. I'm plugging it in for x, right? So this equals 1m plus k.
Negative 1.
Oh, yes, thank you. Negative 1m plus k. All right, go ahead and write your equation out for letter B, okay? Using that same idea, plug in those limits, and then test your algebra skills and see if you can't solve that system of equations using whatever method you want. You can do elimination, you could do substitution, up to you. I could also, if you wanted to, rewrite it instead to be negative 2 equals 3m plus k, right? Because then, how many of us think we're going to do elimination? Maybe a few of us. Substitution lovers out there. Either way, you should get the same answer. So however you want to solve it, take a minute, solve this equation, the systems of equations, and you should end up getting, after you've done that, you should end up getting these two values. Your m should be negative 1, and your k should be 1. Okay, so try solving it real quick. If you need help, let me know.